Okay, set 32, limiting reactions. Question number 4. So we're looking at sulfuric acid solution, which is aqueous, and we're told that it contains a certain amount of pure sulfuric acid, and it was added to a certain amount of magnesium to produce hydrogen gas, and also magnesium sulfate, 7 water. And this is a common thing. Magnesium sulfate often forms hydrates like that, and in fact is even used to dehydrate chemicals in the laboratory. So first off, we're asked A, identify the limiting reaction. Okay, so to identify the limiting reaction, we first need to consider how many moles that we have. Let's check the moles of H2SO4, and you will dollars, I wish it were. And we are told that we had 20 grams of this, and we so first off, we know that the number of moles equals mass on molar mass, and that is equal to 20 grams 0.0 divided by its molar mass, which is, what is it, 98? Well, why did I do that? 98.086. Okay, and when you crack that number through, you'll get something like 0.2039, and store that in temporarily in your calculator to the full detail you can, so you don't make rounding errors. Okay, the number of moles of magnesium by the same process is actually equal to, what is it, the 6.08 grams that we have. 6.08 grams divided by its molar mass, or atomic mass, which is 24.31. I think it is 24.31. Okay, and when you put that one through, you find that you end up with what is it? Some value of 0.25. Okay, now looking across at our equation, you can see that we have a 1-to-1 ratio there, so we can directly compare them, and quite clearly the amount of sulfuric acid is less, the number of moles, 0.2 is less than 0.25, so our answer to A, especially when it's scaled by 1-to-1, is quite clearly H2SO4 is limiting. Let's take a look at B. B is actually asking us how much hydrogen gas are we going to make, I think. So we know that our ratio of hydrogen gas, we get 1 mole for every 1 mole sulfuric acid, and sulfuric acid is limiting. So we first figure out the moles of H2, and that's going to be equal to the moles of H2SO4 times our scaling factor 1 on 1 from our equation. That is, for every one of these that we get, one of these that we have, we get one of these. Okay. And we can calculate that one out to be, we know that is the 0.023. 9. I'm just a bit lazy, I'm just going to copy and paste there. So it's that number. Mass equals moles times molar mass, which is going to be equal to this guy times 2.016. Got you there, didn't I? You're thinking hydrogen. Remember, it's hydrogen gas. That's usually what kills most people who do this particular question. And sure enough, that then can be figured out to be 0.41. Are we going to 1 grams? Yeah, that will do good enough. Oh, so 0.41 grams would do for the level that we're doing of hydrogen. That's the answer to that. C. What mass of the magnesium sulfate, 7H2O, would be formed? Oh dear, this is what scares people, because that 7H2O, it's just the same as anything else. You get one of those, will make one of those, and one of those will make one of those. As this is our limiting reagent, all we need to do is figure out the formula mass of this, multiply it by the number of moles scaled of the limiting reagent, and we're good. That is so easy to do. Okay, this is equals to the number of moles, H2SO4, scaled 1 to 1. Okay, one of those, for one of those, okay, times the molar mass. Okay, put the number into this one, we get 0.2039 times 246.492 for the molar mass, times our 1 to 1, times 1 times that, and that will give us the value of 50.26 grams of magnesium sulfate, 7 water. And that's quite easy to do, that particular one. Let me just clean this up so it leaves a nice residue. I'm just going to put the subscripts in, and then we're done here, aren't we? H2. Oh, beautiful. Ta-da! Hope I got them all and hope they look good. Hope you enjoyed this too and that it was of help to you.